Because random numbers are used so much in building probability distributions, a short review of creating these random values is prudent. Excel's random function is capable of generating a large number of random values without reproducing a value more than once. The rand function is capable of making more than a quadrillion random values. Below, we will talk about the limitations of Excel's built-in random number function and ways to get around their limitations. We'll also look at the random number generator in Excel's data analysis toolbar. So, let's look at Excel's two built-in functions first. First off, there is the rand, shown on the left. This dynamic random number generator is limited to values between 0 and 1. The rand function is used to create the probability inputs to most distribution functions. For example, norm.inv, its parameters are probability, mean, and standard deviation. Another way of creating random values with a built-in function is rand between. It's limited to positive and negative integers only. Note that the results have zeros after their decimal. One workaround to getting random numbers that represent all real numbers is to use the formula of the max minus the min times the rand plus the min. When we look at our table to the left under Custom My Formulas, we can see that the numbers represent numbers after the decimal. We see negative numbers and we see whole numbers as well. So this can create any real number. And lastly, another way to generate random numbers is to use Excel's random number tool in the data analysis tool pack. So let me demonstrate. So I'll click on here and I'm going to go to data and I'll go to data analysis, random number generator, and we're going to generate 1,000 values following a uniform distribution between minus 0.01 and 2.3, and we're going to use a seed. And the seed allows you to reproduce the random numbers each time. And we'll put it in cell E11, so OK. And notice that the numbers are always the same because we've used the seed. But if we run the simulation multiple times, you'll notice that these random numbers do not generate. They are static. So let's move on to finding the mode of random numbers. In this workbook, we're going to look at finding the mode of 1,000 samples from a normal distribution. You may have run into this problem of not being able to resolve the mode of a PDF using Excel's mode function. That is, Excel returns the #NA symbol. The issue results from the use of random values with very high precision. In Excel, there is greater than 15 digits after the decimal, which can produce more than a quadrillion unique values. Hence, sampling of 1,000 random values, as in this exercise, is not likely to produce the same number twice at this high level of precision. Hence, no mode. If we look at table 1 in the first row, we see that we find no mode, or we get the #NA. For your interest, I've done the same experiment with 1 million random samples and still get the #NA symbol. Most distributions use the random values as a probability parameter and subsequently have the same issue. However, I found there are 3 ways to get around this limitation and find the mode. The first being, we can lower the precision of the random values by rounding, as in table 1, where I've rounded it to 1, 2, 3, 4 digits, 5 digits, but afterwards you can see that the precision is too high and end up getting the #NA symbol. Another technique is to bin the data using Excel's frequency function, as we see in table 2. In table 2, we see that the uniform, or the random numbers, look random, and when we look at the distribution of the normal distribution, we see a normal distribution and we see the mean right around 0.5, but this isn't always the case as we run multiple simulations, so let's do that. I'll hit Shift F9 and notice how that changes. And sometimes the mode will be a little bit higher or lower than 0.5. So this isn't the most accurate method. Method 3 uses Excel's XLOOKUP function on the PDF. So we find the maximum density and look up the corresponding values. So let's have a look at this in a little bit more detail. Here's the XLOOKUP function here. and it looks at the maximum probability, or the dist, that's your highest density, and it finds the corresponding value in norm M. And as you can see on our chart, the mode is at 0.5, which is the mean value for our distribution. And if we run this several times, you'll see that even this changes a little bit. So watch the 0.49 and see how the number changes with multiple simulations. But almost always right around 0.5. So which approach is the most accurate? In my opinion, the XLOOKUP method is the most accurate, as it preserves the 15-digit precision of the data. The rounding technique has varying accuracy depending on the precision of rounding, but it's easier to calculate than the XLOOKUP technique. And finally, the bin frequency technique is the least accurate due to the practical limitations on the number of bins. And remember, results can vary from simulation to simulation as random numbers change from each simulation to the next. I hope you found this Excel demonstration useful. Thanks for listening. Like and subscribe.